show that the midpoint of the line segment between the points x1, y1 and x2, y2 is given by the formula midpoint equals the average of the x coordinates, x1 plus x2 divided by 2, comma, the average of the y coordinates, y1 plus y2 divided by 2. So here's a point, x1, y1, and let's call that point P. And here we have a point Q with coordinates x2, y2. We have the line segment here connecting them. And then we have some proposed point M, the midpoint, we'll call it M, capital M. And we want to verify that this is actually the midpoint. So to do that, we need to show a couple of things. We have to calculate the distance between P and M and Q and M, and those two distances should be the same. But now there's a lot of points in the plane for which those distances would be the same. In fact, those points will lie on a perpendicular line. So these distances being the same just means that the point M is somewhere on this perpendicular line, this red line. So we actually want to show that M is on the line between P and Q as well. So first we have to show the distances are the same, and then we have to show that M is actually on this line. And to show that the point M is on this line, we can show that the slope of the line PM is equal to the slope of the line PQ. And that will do it. So let's verify these facts. The distance between P and M, so x1, comma y1, and our midpoint. The distance between 2 points involves a square root. So let's square the distance. Then that will be the square of the difference in the x's, so we'll call that delta x, and then plus the square of the difference in the y coordinates. So the x coordinates, the difference in the x coordinates, if we do x1 minus x1 plus x2 divided by 2, simplify this by writing x1 as 2x1 over 2, so that we have a common denominator, and then subtracting in the numerators, we will get 2x1 minus x1 is x1, and then minus x2. So x1 minus x2 over 2 squared plus delta y is going to be y1 minus y1 plus y2 over 2. So it's going to be this exact same calculation, but with y1 and y2 instead of x1 and x2. And so we're going to get the same result of y1 minus y2 over 2 squared. So that's our formula here for the distance between P and M, the square of the distance. So of course the distance would be the positive square root of that, and let's calculate the square of the distance between Q and M, and we'll get the exact same thing. So we have to do delta x squared, but using Q. So this one's the point Q over here, which is x2, y2. So now we have to look at delta x here, which would be x2 minus x1 plus x2 divided by 2. And we'll do the same common denominator business here. And that gives us 2x2 minus x2 is x2, and then minus x1 over 2. So we're going to get x2 minus x1 over 2 squared. And for the delta y, we're going to get the exact same thing, but with y2 minus y1 all over 2 quantity squared. And x2 minus x1 and x1 minus x2 are opposites. x2 minus x1 is the negative of x1 minus x2. But when you square them, x2 minus x1 squared, when you square this, the minus will go away, and that will just be x1 minus x2 squared. So these are identical, and so distance squared from P to M is the same as distance squared from Q to M, and then you take the positive square root of both sides, and those are equal. So we have verified that the point M is equidistant to the points P and Q. Now, to finish off the proof that this is the midpoint, we just have to show that M is on the line segment from P to Q. So the slope of the line segment PQ is rise over run. It's delta y over delta x between these 2 points. Delta y is y2 minus y1. Delta x is x2 minus x1. And now we just have to verify that the slope of PM is the same thing. So what is the slope of PM? We need to do the same formula, rise over run, but using the points P, x1, y1, and M, which is the averages of the x and y coordinates. So the change in x will be x1 minus this, which we've already done. It's x1 minus x2 over 2. x1 minus x2. Sorry. I'm supposed to be doing the y's first. Change in y over change in x. The y's first, so y1. Okay, so let's do the change in x first. It just goes on the bottom because that's what's here. x1 minus x1 plus x2 over 2 is exactly what we had here, and we got x1 minus x2 over 2, so that goes on the bottom. x1 minus x2 over 2, and the change in y is the exact same thing but with y's in the place of x, so that's y1 minus y2 over 2, and now we can divide these fractions, and we get y1 minus y2 over 2 times 2 over x1 minus x2, and this is y1 minus y2 divided by x1 minus x2, and that's exactly the same as this. Now both of these subtractions are in the opposite order, so we can say this one is equal to the negative of y2 minus y1, and this one is the negative of x2 minus x1, and then the negatives cancel, and we get the slope is y2 minus y1 over x2 minus x1 in both cases. So the slope of PM is equal to the slope of PQ. So P and M and Q and M are equidistant, and the slope of PM is the slope of PQ. So that puts the point M on the line segment containing P and Q. Hence, this is the formula for the midpoint of x1, y1, x2, y2.